So looking at the area of these sort of interesting shaped surface area, if I look at a cylinder, it has a circle on the top and a circle on the bottom. So the area of a circle, well, first I need the radius. So the radius is 20, the diameter divided by 2, which is 10 meters. So each circle would be radius squared times pi, but there are two of those circles. And then if I were to cut down the side, kind of look like at a soup label, can on a soup label, or soup label, can label on a soup can. Gosh, I can almost talk. If I were to cut down the side, it's really just a rectangle. And the width of the rectangle is the circumference of the circle. So that's 20 times pi, diameter times pi. And the height is 13. So I have 2 times 10 squared pi, and then I have 20 pi times 13. And I end up with the surface area, and I'll write this up here, is 1,445.1 square meters. On this box, there's kind of the back end and the front end, and each of those is 10 by 7. That's the front and the back. The two sides, there are two of them, and each of those is 20 by 7. And then the top and the bottom, there's two of those, and each of those is 10 by 20. So I end up with 140 square meters for those, and I end up with 280 square meters for those, and then 400 square meters for the top and the bottom. So then my surface area ends up being 820 square meters. A cone. I said this is the one I would give you the formula for. So the circle part is just pi r squared. You're used to that. But then this sort of fan-shaped part, when I cut this apart and I look at it, is pi times the radius times the slant height. So this isn't a perpendicular height anymore, it's this slant height. So radius squared pi is the circle, plus the radius times the slant height times pi is the rest of it. And then it actually says to round answers to the nearest tenth of a square centimeter. So I'm not going to leave these pi's in here. I'm going to calculate this out. And I end up with 1,719.4 square inches. This composite shape, if I think about what's happening here, there's this cylinder that's a circle on the top and the bottom. But when I look at the number of circles that are exposed, it's just one. So radius squared pi. But I really don't want to do that because this circle is exposed, but the circle on the bottom of the cylinder isn't, and there's this circular shape that's cut out of the top of this box, sort of, that's not exposed. So really, if I take this and I were to move this circle down, that's actually the top of the box, and it's probably going to make it easier just to think of it that way. So in essence, the entire box is exposed. Because yes, there's this circular part that isn't, but then there's a circular part up here that is. So to find the area of the box, all four sides are congruent to each other because it's a square. So there would be four sides that are 5 inches by 1 inch. So that's just going to be 20. The top and the bottom of the box, there are two of those, and they are 5 by 5. So that's going to give me 50. And then the sides of the cylinder are exposed, so that's the circumference of the circle, which is the diameter, so 2 times the radius times pi, and then times the height, which is 4. So that's going to give me about 25.1, again, because I'm supposed to round to the nearest tenth. When I add those together, I get 95.1 square inches.